Welcome back. Getting real close to being able to fly this thing. So 2 more, maybe 3 more videos. This next video is going to deal with some Transport Canada regulated stuff, some maintenance problems, center of gravity, flight envelope, all the stuff that a manufacturer would be required to give you as part of a, manufacturer's declaration. But we'll get into that. First things first, I've got the fancy C of G machine. So we're going to talk about the C of G on this. Mark has marked it, because that's what Mark does. And your C of G is here. So it's right behind this spar. I'm going to tell you, on all my Avro Arrows, and I've built a few, Mark did copy the 3-view plan for him, and my C of Gs almost always come out right around the dog tooth. So his is actually quite a bit forward, which really starts to explain a lot why this thing flies so good. Just real quick. Center of gravity, we all know from modeling, that results in a pitchy airplane, but on these deltas, you get another little problem called center of pressure. And basically, all of this model in front of that pivot point, you got to think of the center of gravity like you're balancing on a ball. All of this side area in front of that is destabilizing if the wind catches it. That's why she's got such a big butt, big tail. But if you move the C of G and the center of pressure forward, you're limiting the movement, the arm of this, and then that's why Mark's flies without a rudder. My C of Gs are always much further back, which is why I always need a rudder, because I have to be able to control this big old schnoz. So anyways, enough of that. What we're going to do now is we're going to show you. I've also gone ahead, and you're going to have to install some Velcro buttons. Again, whether they're round or square or stripped, doesn't matter. But what you want is you want that battery, once we get it in there and we mark where our center of gravity is, we don't want the battery sliding around, especially when you're hand launching. Ask me how I know. So when I make all my connections, I'll tuck it in there all nice and neat. I'm not going to do it right now. And then this strap goes over, and good. Now you can see my battery can't move. That's critical for maintaining your center of gravity when you hand launch. I've seen far too many guys throw, and then the battery slides back, pitches up, crashes. No good. So I'm going to put this on here loosely. That works so good. Okay, and I'm going to set it up on my fancy dancy center of gravity machine where Mark has marked the center of gravity. And it snags on my shirt. Okay, so there is precisely where Mark has marked the center of gravity. I'll just adjust the camera a little bit and you can see my messy shop. So I put the battery in there and I'm already tail heavy. Okay, so we'll just pull the hatch off. What I'm going to do is I'm going to move the battery forward. Maybe like ½ inch at a time. Make sure all the wires are kind of where they should be and that the hatch is back, because that's weight in front of the center of gravity. And there we are. Okay, so I moved it too far. I'll just move it back a bit. Okay, so that's pretty close to perfect for balance. So now what you do, here's what you do. You don't need the fancy center of gravity machine. You can just use your fingers. And this is why I put stickers there, so you can feel the stickers, the little triangle fit. I can feel them, and I can just extend my arms, and there, it's balancing on my fingers. So that's my center of gravity for that particular battery. So what I'll do now, if I can find a black Sharpie, oh, what a messy shop, is I will just go in here, and I'll draw a line, and that line, that line right there, and I'll just go 22. So I know for my 2200 pack, that's where I position it every time. You want to fly a lighter pack, a 1500 is probably going to be further forward. So now you have consistent, repeatable center of gravity information. We're not going to move the C of G too much. Although what you can do, and we'll talk about flight testing, because we're actually not technically the manufacturer, and this is important when I talk about the regs. You are. And you can experiment, you can move the C of G back and get the flight performance you want. I'm going to talk about flight performance in a second, but first I just want to get that C of G down. Some guys will actually put a block of foam in here so that the C of G, so that you can't move the battery forward. But again, it's the battery sliding back that's really the big concern. You can do this for all the different batteries, but that's it. It's constructed. My controls are done. I tested the motor again. The glue is dry. I can take this outside and fly it right now. I almost forgot to do the weigh-in. In this corner, weighing, any bets? Any bets? Get your bets. So this is completed airframe. This is ready to fly. The only thing missing is a battery. So here we go. Can you see that? Oops, set her up. And it's, if you can see that, 431 grams, empty, ready to fly. We had a standard 2200 battery, 618 grams. Mark said the target weight was 650, so we're 30 grams under what Mark had his flying at. And again, that's probably, Mark said he used a lot of epoxy, so that's probably most of the weight. Obviously the foam is the foam, the difference is glue. So we're looking at 40 grams lighter. That's not chump change. Now what if I wanted to fly a really big pack? I've got this 3200, which is, 1,000 more milliamps. That might actually be doable. And there you go, 770 grams. So that's 120 grams over. That's a little bit heavier, but you know what? We'll try it. I'll try it this summer. It's not that ridiculous. So that's it. It's a pretty good weight. 430 grams empty for an airplane that's almost 4 feet long. It's fantastic. Flying characteristics. Deltas, first off, they don't have airfoils. They don't need airfoils. The wing is flat. Flat top and bottom. You can consider that symmetrical. All that really matters is that this leading edge is rounded off, and you will get a little bit of airflow separation, but it reattaches pretty good. On the hand launch, if you get the nose too high, I just need to put this battery in here for a sec. Hang on. All right, battery's in, and we'll even put a hatch on. Why not? Let's put a hatch on. I just like playing with it anyway. Boink. If you get on hand launch, if you get way too nose high, you're getting a lot of induced drag from the delta, and chances are you're just going to end up hitting the ground like this. So if you launch, you can launch a good nose high, but you kind of want to push over and get your angle of attack down so that we can get this thing up to flying speed. Deltas are very draggy when you get into high angles of attack, and this thing really doesn't have the power to power out of that. So you got to avoid that. So probably on your first flight, I strongly recommend having someone hand launch it for you. 2 hands is actually best. 1 hand under her belly, 1 hand on her bum. Give her a push, a flat push. Don't flip it. That works really good. So having a helper, it only weighs, like I said, 700 grams max, so you don't have to be a muscle man to hand launch this. Make sure your control throws. So on my very first flight, again, I'm going to dial in a little bit of up in my trim, just so that worst case scenario, I climb. It's easy to recover from a climb. It's really hard to recover from a descent into the dirt when you're hand launching. So if anything, I'll just overcompensate a little, but really, it's not going to require much up trim. Although it's not a flying wing, but it's a delta. They do need a little bit of reflex, reflex is just when the trailing edge is up that little bit. Make sure the ailerons are 0-0 left and right. There's no torque at all from the EDFs, especially not a 50 mil. So there should be no tendency to turn. If there is a tendency to turn one way or the other, it's probably a warped vertical fin or a warped wing or something you did in assembly. This really should just fly perfectly straight, hands off. And then of course, once you get in the air, my recommendation to you is on the first flight, get some altitude and trim out. Find out, go half throttle and set your trims, enough elevator and aileron trim to where it's just flying straight and level. This is a park flyer. This is not a 400 mile an hour speed demon. The idea is a nice relaxing airplane, something that we just want to see an Avro Arrow in the air. But it will do all the aerobatics. It will fly inverted because there's no airfoil. Upside down is perfectly fine to it. Loops, of course. It's almost 1-to-1 thrust to weight ratio, so you've got really good vertical performance. It will loop from level flight. Aileron rolls, barrel rolls. There's no rudder, so if you're thinking about stall turns, bad idea. The stall in this actually is very gentle. These are called dog tooth, and they're actually pretty good at generating a little vortex right there that keeps the stall very gentle. The wingtips flex a little bit. There's no washout. There doesn't need to be washout. It does not have a tip stall tendency. If you're pulling really aggressive high G maneuvers, well, first off, don't. But if you do, deltas just kind of mush. they don't really stall and brake like normal winged airplanes do. They'll just mush, and then you get behind a power curve, and you won't have enough thrust to get out of it, and you'll crash. So try to avoid that. High G maneuvers, there's only one prohibition really on this model, is don't be doing the, I'll climb up to 400 feet, point it straight at the ground, full throttle, to get up a lot of speed, and then I'll pull up at the last second. When you pull up at the last second, there's a very good chance you'll break the wings. It was never designed for that. This is a fun flyer, a fun foam flyer. So don't do that. We accept no responsibility if you rip the wings off, because you will. But other than that, you know, all the full speed, high speed flybys you want to do in level flight, fill your boots. Just don't be doing the high speed dives with full power. Landing is actually pretty simple. You're going to be landing on grass, so we kind of want to try to not damage the belly. Basically come in under power, keep your power up. It is an EDF. And airspeed is what gives us all of our control. If you get too slow, you lose control authority, and that's when guys get into trouble. So come in with power. You know, I kind of maybe half throttle, and I'll come in, and then once I get near the ground, I just keep pulling the nose up, and then I pull the power off, and she'll usually stop within 2-3 feet. And we don't want to slide on the grass too much, or you'll just destroy the belly. Obviously, you can't land this on pavement. If you land on pavement, well, that'll be one flight, and it's one and done. And that really is everything I can think about for flying it for the Pilot Operating Handbook. I am going to show you now, I'm going to do some power up runs. I'm going to stop the vid because I like them in little segments, and I'll show you the difference batteries can make. Okay, batteries. These new 13 blade EDFs, man, they really crank out some serious airflow, but they're hungry little things. They want 40 amps continuous. So I've got a fresh 2200 in here. I've got actually 6 2200 packs, and on a propeller airplane, 5 of them are okay, but as soon as I put them in here, I'm running into problems because they just can't deliver 40 amps for more than a couple minutes. So I'm going to show you with just a little bit of a prolonged test run, and you can just hear the RPM change, and you'll know whether or not this pack is good enough. So just listen to how this goes. Okay, so it's not very high pitched. You can already hear the RPM is falling off. Got a pretty good push, but that's pretty wimpy. Oh, somebody forgot to shut the brake off. Okay, now, just for comparison, so that's one of my better 2200s. I think I gotta go buy some new ones. Because now I'm gonna show you what happens. So, 2200 Gens Ace, and these are really, really good batteries. So now I've got this 3200, which I could actually fly in here. It's a little on the heavy side, but this is good for 100 amps continuous all day long. So I'm going to plug this in just so you can hear the difference. All right, so just listen to the difference in motor RPM. Much higher pitch, and you can see the blanket, and it'll hold this. It'll hold this RPM on the test stand for like, and yeah, if I let go of this, it's gone, even on the workbench. So all I'm trying to tell you is that if you want to fly this with old saggy packs, that doesn't sound good, but old saggy packs, you're not going to get the enjoyment that everybody else is. So, if you've got good 2200s, great. If not, go buy some. You only live once. You can't take all this money with you, and this is a hobby. So fresh packs, definitely better. And that's it. The next video I want to be doing is I want to be outside flying this girl. I thought there might be a weather window. It's supposed to go down to -21 tonight, and I'm not that much in love with you guys to go and fly -21. But I think there's supposed to be some -4 again later. So if I get the chance, I will go out and do some test flights. Other than that, we just kind of sit. Everybody's going to go off and do their own projects. And come spring, we'll see. Which is, again, another reason I'm doing these videos, so that you don't have to wait for me. You can just open up the video, go back and say, what the hell did he say about this? And it's all in the videos. And that's why I broke the videos out into little sections, so you can just read up what's pertinent to you. So thanks, the closing remarks. Thank Mark very much, Mark Sharp, for giving me the opportunity to do this. I'm super happy. I can't wait to see, even 2 of these in the air at the same time would be fantastic. But if we can get like 6, 7, or 12, or all 13, man, wouldn't that be a sight to see? I'd even just like to see 6 of them on the flight line, ready to go. So I hope you enjoy it. It's a foam airplane. It's a fun airplane, and keep the orange side up.